Welcome back to Regular Chem. Today we're going to talk about LOLO diagrams some more, but instead of doing thermal, we're going to do phase changes. So we have to remember from our last set of videos, the LOLO diagrams thermal, that only one type of energy can change at a time, either thermal or phase energy. So if we remember that, then that makes this a little bit easier. So the first one here says a pan of 10 mils of water at 100 degrees is boiled until it's completely a gas at 100 degrees. So I like to start with my my particle pictures first. So let's go ahead and, and draw our liquid to start. And I'm going to go ahead and give it 2 whooshies because it's at 100 degrees. And there we go. So I've got 4 particles to start with. And it says that it's boiled until it's completely a gas at 100 degrees Celsius. So now it's a gas, which means that the particles need to be farther apart. And let me just erase that little guy there. So 1, 2, 3, 4. So the particles are farther apart again in constant random motion. And remember, because they're at the same temperature, I need to put the same number of whooshies. Now, I need to do my phase energy, and I need to do my thermal energy. Now, as far as phase energy goes, remember up here at the top, it says if it's a liquid, we're going to go ahead and have 3 bars. So there's 3 bars. If it is a gas, it's going to have 10. Now, a little side note tip, if you're not sure how to make that 10 bars, basically every line makes an extra bar. So now I've got 2 bars, 3, 4, 5, 6, 7, 8, 9, 10. So there we go, I ran out of space, but there's 10 bars there. So 10 bars. So I'm starting with 3, I'm ending with 10. My thermal energy, I'm starting out at 100 degrees, so I'm going to go ahead and bring it up, I don't know how many bars, 1, 2, 3, 4, 5, so that's 1, 2, 3, 4, 5, 6 bars, and I'm going to end at 6 bars, which, 2, 3, 4, 5. Again, I'm not really good at making sure that these are to scale, but you get the point. So therefore, my thermal energy is exactly the same on both sides. My phase energy has changed. How much has it changed by? Well, I've got these bars, 1, 2, 3, 4, 5, 6, 7 bars of energy has gone into my system. So what I'm going to do over here is I'm going to go ahead and draw myself, instead of having to draw all those bars, I'm just going to draw the number 7 and show that that is going into my system in order to make this into a gas at 100 degrees Celsius. So remember, either you have phase energy changing or you have thermal energy changing. You cannot have both changing at the same time. Go ahead and try the next one. Hit pause, try it, and come back and check your answers. All right, so for our next one, we have 25 mils of water, so that's a liquid, at 0 degrees. And so I'm going to go ahead and, I don't know, I'm going to use 1 whooshy actually, so let me fix this. At 0 degrees Celsius, I have my liquid, so 3, I feel like making 4. So I'm going to have 4 of these here. And then it turns into a solid, into ice cubes. So remember, a solid is going to be very ordered, almost like students in a classroom. And then the motion is going to be vibration, so I'm going to use little parentheses around it to show that it's vibrating. So it's gone from a liquid into a solid. So it started out for its EP. Let me go ahead and label our phase energy and our thermal energy. Our EP started as a liquid, and so it started out as 3 bars, and in the end, it was only 1 bar. Our thermal, we started at 0 degrees. I'm going to go ahead and use half a bar. That's kind of half a bar or a bar for 0 degrees. And the thermal hasn't changed, so it'll be like half a bar or a bar. So what happened here was I've lost 2 bars of energy. So those 2 bars have gone out of the system. So now those 2 bars of energy are over here outside of the system. They're no longer in the system. Okay? Now continue on with the other problems. If you're still having trouble, see your teacher at some point before or after school. Thanks.